We have used the word work many times. Wake up, we say today I'm going to work. When we're about to go to gym, we say I'm going to work out. We're always using the word work. But you need to understand that the word work in physics and in our daily life, the word is used differently. What is work in physics? And this is examinable. Work is when a force acts on an object and cause the object to move. So according to physics, work is when a force acts on an object and causes the object to move. What does that mean? It means if a particular force acts on an object and the object does not move as a result of that force, it means that there is no work that the force has done. So when we say a force did work, it's when a force acts on an object and causes an object to move. You can see here I'm holding a marker. If I put this marker on the surface of my hand and I start to move it, this right hand is doing work on the marker because the right hand is causing the force to move on the surface of the hand here. The force is causing the object to move, so I'm doing work. Look at this. If I can hold my marker like this, then I start to walk. I start to walk and move like this. Are my hands doing work to this marker? The answer is no. My hands are not doing work to this marker because this object, the marker, is not moving. It's stationary on my hands. It is my legs which are moving, meaning that there is no work which is being done on the marker because the marker is not moving when I'm holding it like this on the palms of my hands. The only time when we say we are doing work, it's when we cause an object itself to move. If the object did not move just like this, you can see if I move this marker up and down by moving the palm of my hand, am I doing work to the marker? No, I'm not doing work to the marker. Why? It's because the marker is not moving. It is my hand that is moving. The only time when I say I did work is when the object itself moves. So back to the definition. Work is when a force acts on an object and cause the object to move. And cause the object to move. And the object is going to move on the surface. The object is going to move on the surface. So this is our introduction for work, energy, and power. We've already introduced to you work. Work is when a force acts on an object and causes an object to move. So notice that the object which the force is working against, it must move. If the object itself does not move, it means that there is no work that is done on the object. And that leads us to a mathematical definition which will say work is the product of the force. This is the force. And the force is going to cause an object to move. Then we're going to have cos theta. The definition of work is this one. Work which is the product of the displacement and the force. As you can see, this definition, it says work is when the force acts on an object and cause the object to move. This is delta x the distance at which the object moves. Delta x represents the distance at which the object moves. What about the F? The F is the force which is causing the object to move. This is the force which is causing the object to move. Then we have cos theta. This theta, it is the angle between the force and displacement. The angle theta, it is the angle between the force and the displacement. Okay, so let's say I give you this example. Let's say I have a trolley, sort of like a trolley. This trolley is being pushed by a person. This trolley is being pushed by a person. Right? You can see that this trolley is moving. I can say the trolley is moving from A to B. This is the displacement. This trolley is pushed 10 meters. It is moving a distance of 10 meters. You can see that there is a force here. There is a force which is being applied from a particular angle by this person. You know, when you push a trolley, you're going to create a particular angle between the trolley and your hands. And your hands are going to apply a force while you are pushing a trolley like that. So the trolley is going to be displaced. It means that the force which this person is applying will cause the what? Will cause the trolley to be displayed. It means work is being done. Why are we saying work is being done? Work is being done because the force that the person is using to push the trolley is causing the trolley to move. So that force is doing work. So the angle theta is the angle between the force and the displacement. Angle theta is the angle between the force and the displacement. You can see that the object is being moved forward. So theta is the angle between this force and the displacement, as you can see. So we're started now. I hope you are with me. So we're going to define work as the product of the force and the displacement. We multiply by the angle between the force and the displacement. As I told you from the definition that work is when a force acts on an object and can cause an object to move. If an object does not move, it means I'm not doing any work. You can see here I have a chair. Here is the chair. If I can do this with this chair, I press it up, I apply the force, right? But my force is not doing well. Why am I saying my force is not doing any well? The force is not causing this chair to move. The chair is not moving even a little bit, it's being pressed down, it is not moving. But immediately, I start to make the chair to be like this. Am I doing well? Yes, I'm doing well because I'm causing the chair to move, right? If I can carry the chair like this, I carry the chair like this. And I start to walk myself. I'm walking while I'm carrying a chair. Am I causing work to this chair? No. The chair is not moving. It is me who is moving. It is me who is moving. The chair will not move. It is me who is moving. So the only time when I do it is when I cause the chair itself to move. It's when I cause the chair itself to move. I hope you understand what work is. Okay. Now, I want us to talk about what we call positive word and negative word. Positive word and negative word. These two concepts, they are very important in this topic of work, energy, and power. And they will address the issues of the angle between the force and the displacement. What is positive work? Positive work is when the force is in the same direction, when the force is in the same direction as the object. Positive work is when the force is in the same direction as the object. What I mean is, if I have an object, the object is moving this side. And also, I'm pushing this object to move this side. So, it means I'm doing positive work. What do you mean I'm doing positive work? It's because the force is moving in this direction. I can call it the applied force. The force which I'm applying, which causes this object to move, it is moving in this direction. Moreover, this object is going to that direction. It means I'm doing positive work because the force and the object are moving in the same direction. Positive work is when the force and the direction of displacement are all going to the same place. That is the best explanation I can give you. Positive work is when the force and the object are going in the same direction. When I apply a particular force, it will push this object to move to this side. And my force, I'm applying it also in that direction. So it means I'm doing positive work. Positive work is when a force and the object are both moving in the same direction. That is positive work. And in your mind, you may be thinking that, is it possible that a force and an object move in different direction? Yes, it is possible. There's what we call negative work. Negative work. Negative work is when a force moves in an opposite direction as the object. Negative work is when a force moves in an opposite direction as an object. So it means a force which is doing negative work, it is moving in an opposite direction as an object. It means that when an object is moving that side and the force is moving this side, there is negative work. I'm going to explain to you, after just explaining these two concepts, what it means to have a negative work and a positive work. I don't want to mix things. So, negative work is when a force moves in an opposite direction, I can say of the object. When a force moves in an opposite direction of an object, the force opposite the direction of an object. The object is moving this side. Let's say the object is moving this side. It's a trolley. This trolley is moving on a rough surface. If I'm pushing this trolley by the applied force will do a positive work because the trolley will move this side and I'm applying my force this side. Understand? But since it is on a rough surface, they say friction. If you don't know this, whenever you hear the statement rough surface, you need to know that rough surface means the presence of friction. Friction is present in all the rough surfaces. So whenever you hear a statement that an object is moving on a rough surface, just know that there is a friction. If you hear that an object is moving on a smooth surface, if an object is moving on a smooth surface, just know that there is no friction. These are also the two concepts that I'm introducing in this introduction. Positive when an object is moving in the same direction as the force. A force is doing positive work if it causes an object to move in the same direction as itself. Negative work, an object is moving in the opposite direction of the force. The force is moving this side, an object is going this side. I was introducing this way to explain negative work. Since we are saying that this is a rough surface, it means there's going to be friction. Since an object is going this side, friction will oppose the motion of an object, and it is always parallel to the object, as we know. So you can see that the frictional force, which will be represented by FF or FK, kinetic friction or frictional force, which some of the representation which are allowed according to the exam guideline. The object is moving in that direction, but the frictional force is moving in this direction. It means that the frictional force is doing negative work. Why is it doing negative work? Because it is opposing the displacement. The object is being displaced in this side, but the frictional force is moving this side. It means the frictional force is doing negative work. I hope you understood what it means. These two, they are the core of this topic of work, energy, and power. They are the core of work, energy, and power. Okay, so let me erase and give you more details. Okay, positive work. Positive work. What does positive work mean? When you get positive work, you calculate the work done and you get positive answer. What does it mean? Positive work, it means that energy is added in the system. Isn't it, as the objects are moving, there's going to be gain of energy or loss of energy. So it means energy is added or energy is gained. Energy is gained. Energy is added or energy is gained. That is positive work. It means the system have gained energy. Rather, some form of energy is converted back to a particular energy, and it will cause the energy to be gained in the system. That's how we can explain in general. That is positive work. But when it comes to negative work, what does it mean? It means that energy is lost in the system. It means the system loses energy. It means that since frictional force is going to do negative work, frictional force is going to cause energy to be lost in the system in different forms. In the form of heat. Friction causes heat. If you can move your hands like this, going to start to feel particular heat because of friction. So friction can cause some of the energy to be lost in the form of heat. So whenever a force is doing negative work, just know that energy is going to be lost in the system. When positive work is done, it means energy is going to be gained in the system. One thing which you need to note, you don't have to think only about friction. Yes, friction does negative work. Even gravitational force, sometimes it does negative work, but I will show you in details in a situation where the gravitational force is doing negative work. Just know, negative work is when an object is moving in that direction, the object is being displaced in this direction, then the force is acting in the opposite direction. That is negative work. It means that energy is being removed in the system. Positive work, when an object is being displaced in a particular direction, then even the force is moving in that same direction as an object. It means that force is going to do positive work. I hope I've explained it correctly. Teachers and people who are in physics, you need to be careful. Sometimes as teachers, when we explain, we need to reduce physics and break it into pieces that learners are going to understand. So some people are more concerned with the use of language or what. Remember, I'm a teacher. As a teacher, I must break these things in a way that learners must understand. I must not use bombastic words. I must not explain in a way which is so mechanical that will cause the learners to fail to understand. I must bring it home. I must reduce. I must act as if this is a general subject when I explain so that the learners can understand that. That's what I'm saying. Negative work, an object is going that side, and then a force is going that side. The force is going to do negative work because an object is being displaced in this other direction, and the force is moving in the other direction. So negative work, energy is going to be removed in the system. So that way of explaining is not more mechanical, but it is meant to make learners to understand, because the aim is for learners to understand what is going on rather than being more mechanical. That is the concept of this channel. Okay, let us move forward. Okay, we can talk about the angle theta when we have a positive work. Positive work. Positive work, it means that theta is equal to 0 degrees. Positive work, it means theta is 0 degrees. Then negative work, it means that theta is 180 degrees. Although we will explain in details, telling you that applied force will use 0, frictional force will use 180, this one will use this angle. But as we explain, we go into details, we may leave the use of all sorts of angles, because there are many ways to deal with this theta. The main two parts is this one and this one. You just need to check, is negative work being done? Then is positive work being done? If we have negative work, use 180. If we have got positive work, you use 0. What is positive work? When an object is moving in the same direction as the force. Negative work is when an object is not moving in the same direction as the force. It means that force is doing negative work. What do we mean by that? Positive work, it means we're going to have cos 0, which is equals to 1. You can see that we've got a positive 1, which implies that, which will make everything in the formula to become positive. And it means energy is going to be gained in the system because there's positive work which is being done. That's why this answer is positive. Then, with negative work, we're going to have cos 180. Cos 180, which is negative 1. You can see we have a negative answer. The negative answer implies that we've got the negative work which is being done and the energy is removed in the system. When you are calculating energy in this topic and you get a negative answer, just know that energy was removed in the system. When you get a positive answer, just know that energy was gained on the system. Okay, I think we are moving very fast in a way that we can understand. Please don't jump this part. Don't jump this video. I know you jump trying to go to the next video. but this video is the most important because we are explaining the basics. Then the other videos will be doing an application. Okay, so let's say we have an object. Here's an object. It's a trolley again. The trolley is moving this side. The trolley is moving that side. It's being pushed by a person. Although I did not draw a person, there's a person who's pushing this trolley. Let us draw a free body diagram of this. We're going to have, for free body diagram, we represent it by writing a dot. Then there is applied force. Applied force is pushing the object that side. So it means we're going to draw a straight line. And please don't ever make a mistake of just drawing like me. It is wrong. I advise all my learners, don't ever use just a free hand to draw. Use a ruler. Draw using a ruler. Don't draw like me as I'm doing here. Because sometimes we draw lines which are not straight. And we expect you to draw straight lines. So we're going to write FA, which represent the applied force. For applied force, we write FA. Then this trolley is moving on the rough surface. As you know that trolleys are going to move on the road. And the road is rough. It is general. Just know that whenever you are told that a car is moving, just know that a car will always move on the road. And the road is rough. Don't wait to be told that it's a rough surface. As long as that thing is a road, you know that cars move in roads. These roads, all of them, they are rough. Most of the surfaces that we have, they are rough. Unless otherwise stated that an object is moving on a smooth surface. It is very difficult to find a smooth surface naturally so. As I told you that the word smooth surface, it means that there's no friction. So rough surface, it means there is friction. Okay. So I told you that the object is moving to the left. Let me write then. Object is moving to the left. It is your left. Let me say it's my right. It's our right. It's moving to the right. So it's being pushed, right? So we're going to have applied force, then we have frictional force. You can write by FF or something like FK. Since the object is on the surface, we're going to have a normal force and we're going to have gravitational force. This is the free body diagram that you can use. So I want to tell you that for applied force, right? Theta is equals to 0 degrees. Why is it 0 degrees? Because applied force is doing positive work. The object is moving this side and the applied force is being applied to this side. So it means the force is doing positive work. If in one of my words I said the object is doing positive work, just know that the correct way to say it is that the force is doing positive work on the object. So if I ever mix the two, it's those things of mistakes, but it means the same thing. But as a scientist, you need to say things in the correct way. Okay, applied force, it implies that theta is equal to 0 degrees. And it will give us cos 0, which will give us 1. Then, frictional force. Remember, frictional force is going to do negative work. The force is moving in this direction. Look at the object. The object is moving in that direction. It means frictional force is doing negative work. So it means we're going to have theta, which is equals to 180 degrees. And cos 180 will give us, cos 180 will give us negative 1. Meaning that this negative work energy is being removed in the system. Positive work energy is being added in the system. You will notice that I've only used applied force and frictional force. I know that we've got gravitational force. I know that we've got the normal force, and I'm very careful, especially about the gravitational force, not to say anything. It's because after showing you how to draw free body diagram, I'm going to explain in details calculation of gravitational force, because with work, energy and power, the problem lies with gravitational force. Work done by gravitational force, because it will depend on where the object is. Sometimes the object is on the incline, sometimes the object is on a just a flat surface. So I must be careful. I haven't said anything about gravitational force. I will show you what will happen with gravitational force. Apply force 0 degrees, frictional force 180 degrees. That is the angle theta. Okay. I hope you are moving with me. Okay, let us talk about normal force. You saw we're explaining applied force and frictional force. Let us talk about normal force. We're spoken about positive work and negative work. There is what we call zero work. Zero work meaning that no work at all. So, forces that acts, I can say that acts 90 degrees to the direction of displacement of an object does no work. Okay. A force that acts 90 degrees to the direction of displacement of object does no work. What do we mean? We are talking about normal force here. We are talking about normal force, which we represent by Fn. Normal force will act perpendicular to an object, to the surface an object is going to move. Normal force is going to act perpendicular to the surface at which the object is going to move. It means that normal force is going to do zero work. And sometimes these kind of questions, they come that why is it that normal force does not do any work? It's because it acts at an angle of 90 degrees to the direction of displacement of an object. All the forces which are acting at an angle of 90 degrees to displacement, it means those angles that are going to do no work. As you know, that cos 90 will give us 0, because this force is parallel to the displacement. As you know, that theta is the angle between the displacement and the force. So if the angle between the displacement and the force is 90 degrees, such kind of a force will not do any work. It is going to do what we call zero work as the normal force. Normal force is doing zero work. I'm going to explain what normal force is into details when we are doing the free body diagram. So we've explained positive work, negative work, and zero work. Zero work, it's actually mean no work done. Zero work, it means no work done. Why do we have a force doing no work? It's because the force is acting at an angle of 90 degrees to the direction of displacement of an object. It means such force will do no work, and that force is normal force. It means the theta for normal force is going to be 90 degrees, and 90 degrees, it means that cos 90 equals to 0. So normal force, you'll see as we will be calculating different work and forces, we won't include normal Okay, let us talk about gravitational force and the work that the gravitational force does. So, we've spoken about the frictional force that does negative work, and the applied force will do positive work. The angle theta will be 0. Then we can talk about the gravitational force. You can't cram and say that gravitational force is going to do positive work or negative work. The answer is not fixed. It depends on how the question is asked or where the object is going. It depends on that, so we need to be careful about that. So before we talk into details about the gravitational force, I want to start by explaining a free body diagram, so that when I explain the gravitational force, it's something that we are able to see from a free body diagram. Okay, let's say there's an object which is lying on the flat surface, like that. It's just on the flat surface lying. Let us draw a free body diagram for this object. We're going to have represent the object by a dot. We write the normal force, which will be perpendicular to an object, and the gravitational force will also be perpendicular to the surface of an object. Then we represent this like that. Let us look at the surface of an object. If ever we were moving this object, if ever this object was moving, of course, depending on what we are told. But now I'll focus on normal force and gravitational force. It means that normal force and gravitational force, in this case, they are doing zero work. Why? It's because that normal force will add at an angle of 90 degrees to the direction of displacement. It means that the angle between the displacement and the force, normal force, is 0. Then, what about this one for gravitational force? Still, the angle between the gravitational force and the displacement, it will be 90 degrees. So, both of them are doing zero work. They are doing zero work, meaning that they are doing no work at all. So, you need to notice that gravitational force does no work if the object is lying on a flat surface. Take note of that. Gravitational force, it does no work if the object is lying on the flat surface, just like this one. But we're going to have a situation. You find that an object is on an incline. Let's say we have an incline like this. We've got the 4 kg box on an incline, which is 30 degrees. Can you see? That's where the problem is going to come. And we need to explore this diagram and learn how to draw a free body diagram also, so that I explain what will happen as far as gravitational force is concerned. Okay, let's start from explaining these things. Normal force. Let us explain what normal force is. A normal force is a force which the surface exerts on an object it is in contact with, this force which is exerted on an object it is contact with, the force will act perpendicular to the surface. What does it mean? It means that you don't claim that when you draw a free body diagram, we will have a normal force all the time. No, don't claim. A normal force is a force which the surface exerts on an object. The only time where we'll have normal force is when an object is on a surface. If I take this and I put it here at the top of this surface, you see, there's a surface. This surface is going to exert a force on this object, meaning that we're going to have a normal force because there is a surface. But look at this situation. If I happen to throw this, to make this to move in the air, or I just take sort of a rope and I hang this on the rope, what is it that is going to happen? This rope is going to form the tension. Then there is no surface. This thing is not on the surface. It means that we won't have normal force, because normal force is a force which a surface exerts. It's a force which the floor exerts on an object, and it acts perpendicular to the surface. It means that normal force is always perpendicular to the surface of an object. Notice that when you give the definition, don't just give the definition and stop where it says it is a force which the surface exerts on an object it is contact with. You need to tell us that, and it acts perpendicular to the surface. That's what the definition says. It means that the normal force at all the time, it will always be perpendicular to the surface. So, normal force is always perpendicular to the surface, and is the force which the surface exerts on an object. Meaning that if the object is not lying on top of something, we want to have a normal force because there is no surface. If we are having an aeroplane which is flying, that aeroplane will not have normal force because it is not on the surface, but when it lands, that's then we're going to have a what? A normal force, because normal force is the force which the surface exerts on the object it is in contact with, and it is acting perpendicular to the object. Okay, let us look at this incline. I want to represent normal force for you. This is the surface. Think of this as the garage somewhere. You know, the garage of the house. The garage of the house. We're going to have a ramp, right? Most of the garages in where we live, in our villages, remember we come from a village. So the examples that we're going to talk about will focus on the village. That's where we're from. So if you check those garages, most of them they've got ramps. So think of this incline as the ramp to enter a garage. You understand? Think of this incline as a ramp to enter a garage. So this is a surface. This is where the car is going to pass through before it can enter the garage of the house. So this is the surface. Can you see? Remember the definition. What does the definition say? It says that normal force is a force that the surface exerts on an object, and it always acts perpendicular to the object. That's why when we draw the normal force, we are going to draw a force which will be perpendicular to the surface. What do we mean by a perpendicular? Let me check this textbook. Can you see this textbook? This line and this one, they are perpendicular to each other. They form an angle of 90 degrees here. I'm holding a solution for all textbook. This angle that is here, it is 90 degrees. So, since we are being told that normal force is a force that the surface exerts on an object and it acts perpendicular to an object, it means that when we represent normal force, when we draw it, it must form a 90 degrees with the surface. We can't draw something like this and we say this is 90 degrees, it is perpendicular. No, this is wrong. You know that perpendicular we must have a straight line and another line which is straight, and they will form what? A 90 degrees. So, just know from today, when we draw not like we draw anyhow. A normal force is a force which is perpendicular to the surface of an object. That's why if I were to draw normal force here, the normal force is going to be to point to this direction. Why is it pointing this direction? So that the angle between the surface and the normal force is what? Is 90. If I were to write an angle like this, it will create this angle. Is this angle 90 degrees? Certainly not. It is not 90 degrees. That's why when I draw, I must make sure that my force point to this direction. Why is it pointing this direction? To create a 90 degrees here. Because normal force is a force which the surface exerts and it acts perpendicular to the object, to the surface of an object. So I must make sure that when I draw the normal force and then I have the surface, I must see the angle of 90 degrees. I must see the angle of 90 degrees. Not an acute angle, something like this. This is not 90 degrees. You know that we find 90 degrees in corners, any corner. In the goalposts, in watch soccer, you know, Pirates is winning. Kaizer Chiefs is not doing well. So I think the goalpost there at the top is 90 degrees. So when you draw the normal line, the normal force and the surface, they must create that top corner of the goalpost. You understand? That's what must happen. I hope you understand the definition of normal force. Okay. Now, let us talk about gravitational force. Gravitational force. So don't cram that we are going to draw a normal force like this. You don't cram. There's no way to cram it. You need to draw these forces from the perspective of a definition. Gravitational force. What do you do with gravitational force? Let me tell you. Gravitational force, it always acts downwards. The gravitational force is always downwards. Remember, a gravitational force is the force that pulls all objects towards the center of the universe. It means when I throw something, this thing, it does not travel up continuously, so it will get pulled. It means the gravitational force, which is I can liken it to a magnet which is on the surface of the earth. It pulls everything that tries to go up. Everything that tries to go up, it is going to be pulled by the gravitational force. So you need to notice, gravitational force, it always acts downwards. So if you want to represent the gravitational force there, you go to an object and you draw a straight line which is downward, a vertical line which is downward. I usually tell my kids that they just say, wow, wow, that is a line. You just say, wow. You draw a line which is vertically downwards. That is gravitational force. It does not matter the surface of an object at which you are drawing. It doesn't matter the surface of an object. If you want to represent gravitational force, you go to the object, you draw, wow, a line which is vertical downward. Just like here. If I want to draw gravitational force here, I'll draw a straight line, wow, facing downward, and I say FG all the time. If an object is on a flat surface like that, if I want to represent gravitational force, wow, I draw a line which is downward, FG. Whether it is on an incline, whether it is anywhere, if I want to represent the gravitational force, what do? I just say draw a straight line, wow, straight line which will be downwards all the time. Then I draw an arrow must point downward because gravitational force is always downward all the time. Okay, so that is the gravitational force. Okay, just give you a buzzer and talk about frictional force. What is frictional? What is frictional force? Frictional force, this is a force that opposes the direction of motion. A force that opposes direction of motion of object. I know you are stopping here, don't stop here. And X parallel to the surface. This one is not perpendicular to the surface. It is going to become parallel to the surface. For example, if I said to you that this box is going up, if this box is going up, it means the frictional force is going to oppose the motion of direction of an object and it will act parallel to the surface. It means that the frictional force is going down since the object is going up. You understand? It means that this object is going down like that. And I mean the frictional force is downwards. Then if the object is being pushed, it means we draw an arrow going up. But take note, you don't claim that because an object is moving forth, it means there is an applied force. It is possible that the object can move forth without an applied force. So you must read the question in here. If the object is being pushed or the object is moving on its own, so an object can move on its own going forward without an applied force. So be careful of such things. Okay, gravitational force, Fg. So now, we're about to explain the work done by gravitational force. I've explained the main thing which I wanted to explain, which is the normal force. That you don't claim that normal force you're going to draw it in a particular way. You need to know that normal force, you just have to draw a line which is perpendicular to the surface of an object. Okay. Yeah. They say an object is moving up the incline. Look at what will happen. Here's an incline. Can you see the incline? 80 degrees, right? I draw it here somewhere. It's 4 kg. This is 4 kg. It is moving where? Up. Now we want to talk about the issues of positive work and negative work. In the diagram which I just erased now, I said that gravitational force, it is always acting downwards. And you agree from common sense that gravitational force is a force that pulls all things to move, to come down. Gravitational force will attract all the things to come down. Surely it means that gravitational force is downwards. So let us look at this situation. We are told that the object is moving up. We are told that this object is moving up. So let us look at this situation. In which direction is gravitational force moving? The object is moving up. Which direction is the gravitational force moving? Gravitational force is going to move what? Down. The gravitational, I've already told you that when you want to represent gravitational force, you draw a straight line which is downwards, Fg. You see that? So, since the object is going up, the gravitational force will act down because it is always downward. It means Fg, it means gravitational force is doing negative work. Gravitational force is doing negative work. I hope you understood, right? Gravitational force is doing negative work. So some people, for theta, when gravitational force is doing negative work, it means theta is equals to 180 degrees. Cos 180 is equals to, cos 180 will give us negative 1. Some people, they do not do it like that, they do it like this. We can write as a note. When an object moves up the incline. Cos theta is equals to 90 plus the angle of the incline. Hey, the angle of the incline is 8, right? Because this theta that I'm talking about the theta from the formula. So I say plus angle of incline, so that you can understand. So it means since the angle of incline is 90, what will we have? we'll have theta is equal to 90 plus 30. And 90 plus 30 will give us theta is the gravitational force. When it is on an incline, it is going to do well. It's either positive work or negative work, depending on where the object is going. If the object is going up, gravitational force is going in which direction? Downwards all the time. It means gravitational force is doing negative work, because object is going up, gravitational force is downwards all the time. It means there's negative work. As I explained to you, that negative work is when an object is going in opposite direction as the force. What about if the object is going down? When the object is going down, it means the gravitational force is going to do positive work. Why positive work? Because the object is going down and gravitational force is always downwards. Gravitational force and the object are moving in the same direction, so we're going to have positive work. I hope you understood how gravitational force behaves. Although I'm going to explain in details as we do questions, but we haven't reached a point of questions now. We still need to exhaust these things. We'll also talk about wave energy theorem. We'll also exhaust more the gravitational force, because the problem with wave energy and power is gravitational force. Ladies and gentlemen.